Hi there. This is all about Oracle policy modeling and travel compensation. But in fact, it isn't about Oracle policy modeling and travel compensation at all. As I'm sure you all know, travel compensation is a project which is provided by Oracle for us to understand and learn how travel compensation works and how you can use the ideas in this to learn about Oracle policy modeling. And anyway, many of you will have seen this before. You can create a flight details, and then you can get a example of how much compensation you would be due if the flight was cancelled or you were denied boarding or one or other of the various situations that are supposed to be taken into account by the EU regulation 261, and this is based on the 2004 legislation. So now we know what this is. If you didn't already know it, I can thoroughly recommend it because it's a great way to learn. It has a bunch of rules, and some of the rules are very interview oriented, so how to manage some of the user interface elements, but most of them are essentially based around the entitlements that citizens have if you live in the European Union when your flight is delayed, and of course the different conditions that are attached. So we thought it would be fun to take this and implement it somewhere else, implement it in another tool that many of you will have come across, specifically Camunda. Camunda, for this little demonstration, what have I used? Well, first of all, I used the developer quick start, which is called C8 Run or Camunda 8 Run. It has significant advantages, is that it can be downloaded and unzipped basically very quickly. It requires OpenJDK, so you'll need to set it up so that you can execute Camunda with its own Java home. If you've already installed Oracle Java JDK, you don't want to break that. And for this particular demonstration, we're going to focus on two parts of Camunda. We're going to focus on Operate, which is the web interface which will allow us to study how things are executing or not. And we'll also focus on the modeler. So let's take a look at how those are installed on this system. First of all, the backend, the Camunda 8 C8 run. You can see that it's basically started and stopped from the command line. This is all fully documented on the website. And when you start it successfully, you should, all things being equal, be faced with the operate login, and the demo package has a demo user and demo password. And you can see that I'm going to be looking, and this won't surprise you, I'm going to be looking at processes and I'm going to be looking at decisions. Obviously, from an Oracle policy modeling perspective, we're interested in decisions, but executing them will be interested in processes as well. So you can see that I've already been running some decisions through this engine, and you'll recognize these perhaps as what we would call attribute names or public names in Oracle Intelligent Advisor, Oracle Policy Modeling. And you'll see that I have a decision instance key, which, as it's probably you can guess, is just the unique instance of that decision being executed. And in my case, they are also attached to a process instance. So we're going to create a process which will execute one or more decisions. If we drill down into the decision instance key, you can see that in this particular case, I was doing a test, and I was testing this particular public name, which is deciding whether a carrier, an airline, is an airline within a member state. And this should look very simple to you because it's all about, do you belong to one of these countries? And if so, it's true. If not, it's false. You can see that the input in this particular test was carrier country is France, and the output is true, meaning yes, it is a carrier from that country. If I drill into the process instance, you'll see that this was actually part of a process, which we'll talk about and see in due course, where there were actually several flights in this case. There was one flight between France and Germany, and there was one flight between France and Spain. But the point I'm trying to make is that the operate is where you're going to be looking at processes that you have been executing or have executed, and you're going to, if you're using decision logic like we would likely to do as Oracle policy modeling people, is we'll be looking at decision instances. And you can see that I've been testing a whole bunch of stuff here. Great. So that's what we're interested in from the execution point of view. Can we test and see what's what? We're also going to be interested, in Camunda Modeler. Camunda Modeler, as its name suggests, is the modeling tool that we're going to use to build our processes or build our decisions. It's a straight download and unzip and run, and it's called Camunda Modeler. And let's bring it up here on screen right now. So Camunda Modeler, if you're from Oracle Policy Modeling, really shouldn't be that much of a surprise, in the sense that you drag items onto a page. It'll feel a little bit like building an interview. And you can build multiple things onto a page, and each thing on a page could be a table like this one, or it could be an expression like this one. So if you're looking for a sort of easy way to grasp this, think of these as rules, and think of these as intermediate attributes. They're expressions that you're going to use to, for example, take two attributes and multiply them to get another attribute. You don't need a table for that. You can just write a literal expression. So you can see that this particular set of tables and expressions is all messed up together with arrows. And if you read the previous article, you'll see that this is a classic example of what not to do. But these arrows don't represent kind of execution. It's not like step 1, step 2, step 3, step 4. They are essentially what I would call requirements. That if you want to calculate the compensation amount, you require this piece of information. So if you want to calculate the compensation, which is the final step, you have requirements coming from 3 different places, which themselves have also got requirements. So it's more what is called in the XML file that's sitting underneath all of this is an information requirement. And obviously for this to work, those information requirements need to be correctly set up. You need to know the logic, just like you do when you write an Oracle policy modeling project and you think about the outcome and you think about the inputs and you think about the intermediates. This is exactly the same thing. This is our final output. These are our inputs. And many of these are intermediates that we calculate either to make our lives easier or because we want to express an intermediate and relate it to the final decision, rather than complicating our lives and trying to make a final decision that's based on lots of inputs. It's exactly the same design methodology as you would have with an Oracle Policy Modeling Word document or a decision service in Oracle Intelligent Advisor. The tables themselves, as you can probably tell, very similar. You can have true, false. You can also have, if necessary, calculations in here. This is actually this dash. You can see is the equivalent of saying everything else. I'm generalizing because this is not entirely true what I'm telling you, but for someone coming from OPM, this will do. Your hit policy is basically, is it a unique row that you're looking for? Do you pick the first if multiple? Do you pick any of them? So it's basically how you handle getting the result out of this table. Most of the time in Oracle Policy Modeling, we would have the equivalent of first, which is whichever line wins first, wins, even if there's another line in there. And let's take a look at another table with a little more information in it. Yeah, here we go. So here's another example. So when the flight distance is less than 1,500, it's a short flight. If it's between 1,500 and 3,500, this is just an example of the fact that you can have ranges, and the syntax here is include, and that's exclude, in case you're wondering. And you can output. Of course, you don't have to just output booleans, you can output text, you can output numbers. Yeah, this is pretty much what you'd expect, right? So this particular set of tables drives a travel compensation. And this is the final table, if you will. So if you were denied boarding and you were cancelled, then you are entitled to compensation and you will have a compensation amount. The compensation amount may be reduced because in certain circumstances, depending on the distance and the delay, a reduction may be applicable. And the reduction is calculated here to say that if you are applicable for a reduction, then you only get half the amount. Again, a lot of this should look very, very simple and very, very familiar. Not just for the fact that it looks familiar as if you've looked at the travel compensation project, but it's familiar because it's not difficult to understand if you're coming from Oracle policy modeling. Now, in order to work with this, as you would in OPM, each one of these tables, you can execute them as a REST API, so you can test them yourself. You'll notice down here is you can deploy from here, so if you need to deploy, you can just click this button and deploy it. And you can do that for any of them. So if you're a Postman person, you can then go and find a nice little API which is public, publicly documented, and you can push all of your inputs in and hopefully get an answer. But once you've gone beyond testing all of these different components, as far as executing the whole process is concerned, what you're going to need is you're going to need a process flow. Now, in this case, this is the world's simplest process flow because the process flow only has one step, and that one step is to execute a decision. And you'll notice that this decision is this one up here, the final one. So to be able to get this, you're going to need to do all of these. So you don't need to have to tell it to do all of these. You simply say, I want that, and it starts going off and looking for the information requirements and working through it. So at the end of the day, this should execute your process, which will execute your service. And down at the bottom here, which I think is a neat trick, you have the task test, so you can actually run it straight from here, drop in your example, and get the answer. So you can play around with that, or you can, again, you can deploy from here, or you can just run a simple single shot. You just want to test it without seeing the test interface. You can do that right now, and then you could go off and look in operate, and look at your processes and see if you have any processes that have been executed and work your way through it. So anyway, so now you know why we're here. We're looking at executing a process, and that process will execute our decision matrix. As you'll recall from the previous examples in the articles, we actually went one step further and we built ourselves a multi-flight calculator. So this was to introduce the concept of, well, how do I handle an entity, what we would call in Oracle policy modeling an entity. So we created a sub-process which is multi-instance, and the multi-instance process will allow us to pass in a collection of flights, which will be made up of individual elements called flight. Each flight will output a single result, which will be wrapped into an array of results. So it's basically telling us that we want to do our service multiple times, and we want to package it all up, and we want to execute it as a set to simulate, if you will, having a set of entity instances that are passed into a interview or into a web service in Oracle Intelligent Advisor. Other than that, this is the same process. This is the same decision table. This is literally just the same decision table. So it's calling, so my process is calling the decision service. That's all it's doing. And if we scroll down, you'll see that you recognize, I'm sure, the inputs in this case, which we did have to map because we are passing from one to another. You actually need to set up the inputs. When we're executing it natively just on its own, provided we send data in using these tags, it'll work. But you'll notice that we've got now a mapping, which means that this will receive flights, and each flight will be mapped into my decision service, or my decision, using these inputs, which should be in the input of my, it should be in the body of my REST. So I'll have multiple instances of this, and each one will be mapped individually into this for execution. And as we saw earlier, we have the output for each individual execution is a single result. So the structure shouldn't look very difficult to understand or very complicated. Again, once you've deployed this main process, you can go away and you can test it on a web service. So you can see that in this case, I am testing the multiple version. By definition, it makes logical in a BPMN sense is that these will be asynchronous by default, but I've switched it to await completion, so I can actually execute it and get the response just like I would if I was executing, the batch assess, or sorry, the assess XML or something like that. You can see that I have 2 flights. In fact, let's change this one to arrival country Ireland, just to prove that I'm not messing around. And we'll say I was delayed for 160 minutes. In any case, denied boarding, false flight won't make any difference because you're not entitled to anything here. But because I was denied boarding and the flight was cancelled, I should be entitled to something here. I'll go ahead and execute that. So you can see that for France-Ireland, I was given a compensation amount of nothing, but for France-Spain, I was given a compensation amount of 250. If I go over to my processes list, and I look at my finished processes, there we go. We'll see that's one dated 20th of November, that's right now, and it was this process. And you can see that it actually executed the internal parts twice, because there were 2 sets of flights. Sorry, there were 2 flights in the set of flights. There were 2 responses that were packaged up into our result set. So we can see that this has been built and executed as you would expect. Anyway, so the final part of this video, and indeed this is what the article actually talked about, was suppose we want a user interface. Suppose we want to make an interview. Well, I mentioned that there is within Camunda Modeler the concept of a form, and you can build a form, but it's very sort of mono-instance task-oriented. There's no way to build essentially an iterative kind of. There's no such thing as an entity container. It's probably, or an entity collect, is how I would put it. So what did we do? For a little demonstration. Well, we used a technique that we've used before. Specifically, we used 2 components. We used a front end and a back end. The back end is really just a way to have a single proxy that we can call to perform execution of our process, or whether we want to extract information from the definition of the decision, or extract definition information from the BPMN itself. So instead of calling whatever this URL was here, we can call our own invented URLs like metadata and execute, and we can then handle packaging it and sending it to the Camunda backend. We're using this technique because it reminds us of all the other examples we've done in the last few months, and specifically we've got a little schema builder which does exactly what we did in the previous examples about the Flow Engine API or the Chat API, is extracting metadata, finding out what kind of fields are necessary, what kind of value lists they have, or what kind of display type they have, like drop down, checkbox, and so on, and building a JSON file so we can then create the user interface on the fly based on this. So the front end should look fairly familiar. We have components like a checkbox, a drop down, a number field, also for the results, how are we going to display the results? And we have essentially a tool for building the dynamic form based on the number of different fields that you have. And we have also got the wrapper, if you will, and in the wrapper we are going to simply execute once the data has been entered by the user. So when the user clicks go, we will execute the process, passing in the flights that have been entered by the end user, and then sending them off to Camunda and bringing them back. So it's just a front end for our BPMN and DMN. So let's close that and let's move to this. So this is an example of what it generates. Yes, I know it's ugly, but it simply proves a point, is that in this case, because we were able to identify the fields and the field types, and also that it's multi-instance, we can now create our, let's do Austria to somewhere interesting like Estonia, and it's an Austrian carrier. I think that's about 850 miles. I have no clue. Let's say that you were delayed for 240 minutes and your flight was cancelled, and we'll create a second flight and say this one is between Finland and Ireland, and it was on a Finnish airline. That must be at least 1,300 kilometers. I have no idea. And let's say that you were delayed for only 60 minutes. You were offered a rerouting, so you shouldn't actually get anything for this. We'll hit run process, and we can see that for the first flight we were entitled to a compensation of 250, and the second one we didn't get any compensation. So obviously from the sort of strategic point of view, you can see that this was just an execution of our process. And you can see there's Austria and Estonia, and Finland and Ireland. But our front end displayed a dynamic form, then wrapped all the data into a format which looks just like this, executed it, retrieved the response, and then displayed the response in this nice little format. So our interview, now of course, I'm not saying this is the same as the interview that you saw in the Oracle policy modeling file, of course not. But the point is that you could use a very familiar structure for your custom built rendering engine, whether you're using Oracle Intelligent Advisor or something else. So we're doing exactly what we did with the Flow Engine API, exactly what we did with the Chat API. We are extracting whatever metadata we have, using it to build the front end, packaging all the front end data entry, and sending it back to the back end in the format that's required, courtesy of the back end piece. And that's it. We had a lot of fun. The front end and the back end and the BPMN and the DMN, they're all on a private GitHub repository. If you're interested in having the contents of these little examples, if you're a gold member of the website, you'll be able to get those for free. I hope you have had a nice day with me, and I look forward to seeing you again soon. Take care. Bye-bye.